with a seal around the inside of it. Technically, that's a Dowty seal invented by Sir George himself. He was a most remarkable character. Not only was he in aircraft equipment, then into seals, and then into mining machinery, where he sent the same Fountain Barber, the pilot we just heard about, to go down the mines to go and find out about mining machinery, to exploit the opportunities after the war. And if we can move on some slides, we can move to the next slide. Well, Martin's just talked about this, so the next slide. So for 50 years, so the story is for 50 years, Dowty was a single product, single industry company leading the world. So the bad old days of pit props. So we had, there were sticks for pit props, timber sticks, and the problem with these, first of all, you had to cart them into the mine, but secondly, you then had to make them fit, and thirdly, when the roof came in, they snapped like matchsticks, and once they snapped, they were worth nothing. So the challenge was to come up with something that would absorb the movement, and that's where George Dowty, on the next slide, developed the so-called Duke prop. So 20-ton Duke prop, which he patented in 1948. So, and if we go to the next slide, a remarkably clever device, because inside here we've got a hydraulic cylinder which holds the oil tanks in them inside. The bottom here is where you pump the fluid. There's a handle up here to pump it up, so you could pump it up to the roof. Inside the bottom here, there's a relief valve, so as the roof closes down, it doesn't build up too much pressure. Also in here is a release valve, so you can collapse the whole thing down. Through the middle is a spring, so it collapses by itself. Up the top there's a breather valve, so it doesn't go and leak the hydraulic fluid on the floor. And over the years, something like 5 or 6 million of these things were made. They were licensed to other countries around the world, particularly to Salzgitter in Germany. But the next thing was how to mechanize that. To the next slide. This had to be set by hand. So here's a forest of them, as you see on the face. So long walk, the coal face on the left, the forest of these props here, and you've then got to keep on moving them forwards. This, incidentally, is a MECO conveyor. So the next thing was to put them together in 3s and 2s. So this is what's called a roof master. So there's 3 props here and 2 there. And the idea was that these shuffle their way forwards. And by shuffling their way forwards, you're always supporting the roof above. So one released, and then set the other one released, set the first one. So no longer did the man have to advance them. Now it was done by means of hydraulic rams instead of by manual method. So the next move was to bring those together. So 2 became side by side to make altogether a 6-leg chock. So we've now got 3 legs here and 3 legs here, and a hydraulic arrangement in the middle here to advance it. So now that one's been advanced, that one's about to be advanced, and the whole lot moves forwards. So this is what the whole thing looks like when you're down underground. Now, I know some of the people here are very familiar with coal mining, but others may not be. You're looking along the face. This face might be 150, 200 meters long, so you're something like from here halfway back to Chance Street, and you're crawling down memory lane at the time. So now we're at the same sort of time as when those supports are being made. Here's the A46. Here's the road going to Ashchurch over the railway line, old railway line. This is the old railway line in place, and the main railway line's going up here, and the motorway is over on the left here. So the factory, the custard factory, is here. That's Dowty's number 2 factory. By this stage, there's Dowty Mining's main office factory, and also by this stage, that was the number 24, I think 24-1 there. So even by the mid-50s, Dowty had got to 24 factories around the place. This shows it now a step on. You've now got a car park here, and Dowty Seals is here, only a few years later. And to the next slide, same thing. So now you can see it in glorious Technicolor. So you can see the whole business has expanded enormously from where it would have been just in the beginning. So this shows the scale that this business was at only some 10 or 12 years after the first prop was invented. It's a staggering achievement. So, as I said, there was a lot of work to crawl along the face backwards and forwards. So throughout this story, there's the need to automate the longwall face. The National Coal Board, way back in the 50s, had the remote operated longwall face, ROLF for short. Had no chance whatsoever of working, but they invested money in it nonetheless. And Dowty was involved in that development. Just so everybody understands what we're talking about in coal mining, So it's all underground mining. There's no open cast in this. And we're probably 200, 300, 400 meters below ground level, depending on the type of mine we're in, maybe more than that in some parts of the UK. And the business of roof support is all about application engineering. In fact, the Dowty business was about application engineering. Clearly, the Lancaster bomber landing gear will be nothing like the landing gear for Hurricane or anything of the sort. Everything is being designed, application, application. Dowty wasn't very much involved in making products. He was involved in solving problems. If you read his story, his memoirs, it's all about how did I solve this problem? How did I solve that problem? That's how he thought. No two customers, certainly when I was involved, ever bought the same specification of supports. Sometimes one customer, or many times, one customer would buy the same support again, but everything was designed for each individual customer. A critical decision in the life of Dowty was the decision to export. Because you got British National Coal Board, who were inward thinking, small scale, standardization, sterilization. If you invent something, give us the patent before we'll buy it off you. We don't want to go and have other people, you having a monopoly of supply because you've got a patent. That was the sort of mentality. Go to the big world and you can go exporting as a different story. Not very much later, we're supplying, this is going, big chocks going to Utah. Go to the next slide. Right, in these supports, you've got however many legs holding the top beam up. But the only thing connecting the top beam to the bottom are the legs. And the roof naturally moves backwards away from the face. That means that the legs get racked backwards, which then in turn bends the legs. And the other thing is that if you run the supports too close together and they squeeze each other on the canopy, when you bring the support forward, you bend the legs. So the next step forward was the shield revolution, where if you flip on to the next slide, and then the next slide, in here, there's a pantograph linkage at the back here, which means that that point goes up and down vertically because of the links. And the legs are now only just acting as hydraulic cylinders. We've now got hydraulic cylinders. That means we can now run the supports literally skin to skin. They rub against each other, which means we can keep the coal out, the dirt out better. So we move on. We have different, as I said, application engineering. We're now supplying to Belgium, 4-leg chocks here, chock shields. So this is a 4-leg shield going to America, I guess. So this is a big China support, 550-ton support. We did 15 faces of those to China in the late 70s. And then this is, I don't know, 3.5 meters or so that goes to, up in northern New South Wales. But again, designed for the application. So thick seams, it could be thin seam. We did one for China. I think fully extended, it was about 1.2 meters high. Very thin seams. So different applications all the time. Dowty was a great investor in people. Sir George was an investor in people, and it carried on. Apprentice training, we had skilled machinists trained, tool makers, production engineers, designers, draftsmen, accountants, admin, secretarial, a whole range of investments. And the investment didn't just stop there, moving on. The canteens, sports and social club, bus transport. On one of those pictures back there, I should have pointed out, there was a fleet of buses on the car park because we were busing people in from all the villages around. In fact, in the first picture that I put up there, there's hardly a car to be seen because people would have been either coming in, I think, by bus or alternatively by train into Ashchurch. In fact, the start and finish times were designed around the timetable of the trains. So by this stage, 1980, the whole lot has got a lot bigger. And you see all this white kit here on the floor. Those will all be all the components of the shields before they got assembled in this factory here. So the supports will be designed in here. They'd be tested across here. The valves made in here, hydraulic cylinders in here, fabrications bought out from somewhere. And I say somewhere because often we'd be supplying kits of parts to, say, Australia, and the fabrication's made in Australia, supplying to Mexico, the fabrication's made in Mexico, in Yugoslavia, the fabrication's made there. It gave us a route into those customers because they had their own fabrication facilities, helped reduce their, if it was a country that's short of foreign exchange, helped their foreign exchange, and helped the politics of the situation as well. And then to final assembly here, dispatch and away. My wife said that I should point out here that in the front here, she once went and parked her little car, a little deux chevaux, and she was quickly hurried round the back. You can't go and park beside those Jaguars. Heavy-duty equipment was started to be bought from the National Coal Board, which was the benefit of the export technology coming back, but again, it had to be application engineered. Some went into the bigger mines, but if we move to the next slide, you couldn't put the heavy-duty supports into the old mines. They wouldn't fit in the cage, they wouldn't fit down the roadways. So here's a support deliberately made narrow, deliberately made short, so that it will actually fit inside the cage. The next one is not actually even a shield, it's got a linkage arrangement, but it's not actually a formal shield, but it's down for very thin seams, that 0.6 of a meter, and up to about 1.4 meters. So that would be probably for a mine in the northeast. But again, application engineered for very thin seams. So control systems were a major aspect of the roof support. You've got the structures on the one hand and the hydraulics, and then you've got the control systems. Careful what I say here tonight, because we've got an expert on this in the room. But the first task was to have adjacent control. The law of the land tells you what you can and can't do. You can't operate a support when you're sitting inside it. So you've got to operate the next door one. That means all the control hoses have got to go across the gap where there's all the movement going on. Quite a good way of breaking hoses. So the next thing is the hydraulic fluid mustn't be oil, because oil will catch fire. So you use water for the hydraulic fluid, which is piped into the mine, mixed with some emulsion to stop it causing rust. It often comes in very hard, it always comes in very dirty. And then there's the need to automate. It's a horrible environment. Dowty was up for the challenge with this, with the Dow valve system they introduced, which, contrary to what happened how many years earlier when the fountain barber was sent down the mine first, this was not so good for the mining environment for a variety of reasons. We go to the next slide. Clever piece of engineering, because in here we've got a rotary valve which operates in that direction and in that direction through a multi-core hose, 10-core hose, 10 mini hoses going this way, which operate the valves in the next door support and in that support. The problem was the thing was very big and it was very sensitive to dirt. It used to drive some of us crazy how often the valves were failing. The good news was the competitors wasn't any better from the valve failure point of view, but it was better from the fitting point of view. Installed, here it is installed in a support, huge great thing, and they even had to go and put some other valves on the outside. The next part, I'm going back to this slide again, because the next part of the story is about how you actually automate the whole thing and what you're trying to do. So we're now into making sure the man never has to go up and down, has to be operating every support one by one, because particularly in thin seams, that's very hard work. So what you've got to do is try and have an electronic control to operate it. The original hydraulic controls, hydraulic automation was never going to work. So you're operating a wave of activities, operating to push the conveyor, operating the supports, as well as operating the shearer as you go up and down. And the long-term objective was to get the machine, as it went along, to tell the supports what to do, so they would operate the conveyor and they would advance themselves. So that was the objective that was set from a relatively early stage. The problem was everything associated with getting there. So electronic control. First of all, it's the same in a challenging environment. It has to be what's called intrinsically safe, which means there's so little current and so little voltage, you can't ignite methane if it was to short circuit. So you basically got virtually no power to deal with. You've now got, so the next thing is you've got some mega powerful equipment working in the environment. Great big shearer, probably working on 1,000 volts, maybe 3,000 volts. You turn on a motor on that, 1,000 horsepower motor, and a huge rate surge, spiky circuits all over the place. just what electronics don't like. So you've got big, then the coal dust. You've got coal dust all over the place. It's quite a good conductor. Carbon's a good conductor. And to keep the dust down, you then put in water spray, which is even better, coal and water. So keeping the electronics in the right place is extremely difficult. And then you've got the mechanical damage from things hurting it. So, and then you've got a computer in every support to talk to each other, and they've got to behave, otherwise it doesn't work. And if anything goes wrong, you've got to go crawling back along the face, fix it, and then come back again. If that happens too often, you give up. Moving on, T was of the essence. The early designs were outsourced. When Dowty bought his electronics division, they then got moved there. But a major move was to bring the whole lot to Ashchurch in the mid-80s. Bit of into divisional politics, you'll understand, going and taking them out of one part of the group and putting them in another. But that was a major step forward, and from there on, the electronics revolution really began for Dowty Mining. Electronic control then became the norm. So here you see put two buttons operating it. One pushes the conveyor, one operates the support. We've got supports now which are regularly being fitted with electronic control. Yes. So now also we've got a close partnership developing with Dowty Meco in Worcester. Meco a while ago had been rather behind the game, but they'd rapidly caught up during the 80s and now were hugely complementary to Dowty Mining. So we're now selling the entire longwall system. And this really changed the game for both Worcester and for Ashchurch. So, and we're now into developing a valve that's designed for the job, designed for the underground environment, very compact in one direction, and a spool valve arrangement, easy to maintain and easy to work with, and also easy to put electronic controls on. We had a problem, what do we call this thing, before we dreamt up that. Lucky character, this good character, we ran a prize, he won the prize for the name of the compact valve system. And that's me giving him his check. We're now going on however many years from that, so that would have been the mid-80s. In 2021, I still found 22, Komatsu, who now own the business, still use the compact valve name. So 30 years on, yeah, he came up with a good name. And now electronic boxes are getting more and more user-friendly, and they became critical to the success. So a good control system was the way to win the face. So by the late 80s, this was really critical to the business. We're also investing in technology. Next slide. In the early 80s, we invested heavily in early days of CAD. And this was actually well before what was going on down at Rotol. People would say, oh, you must be getting this from the aircraft industry. No. And one of those seats was £40,000 a seat then. So you've got to kit out 25 designers, you're talking of £1 million. My son tells me that you can get a much more powerful system now for 1/10 of the price. But in those days, it was expensive, but we believed in it. It was a really major impact for us. And moving on, it enabled us to know where the stresses were in supports and design better supports. It was also a good selling tool. We're also investing in big machine tools, big computer-controlled lathes, robotic welding to get high-integrity welding for difficult to get at places. Also investing in after-sales support. So here we are repairing these gentlemen with the American caps. You can tell which part of the world they're in. I think this one's in Australia, repairing a gearbox. Here, repairing a sprocket. So we're giving a complete support and service to the mine around the world. And this was a major aspect of being able to win business and support business, and also have continuity between roof supports and conveyors tend to be a bit spiky. You get an order, then you might have to wait for a while for the next one. But in the meantime, this is a before and after of a report. Support comes back for repair looking like that and goes back to the customer looking like that. The objective was send it back virtually as good as new, but as a fraction of the cost. All the time was how to make coal cheaper to mine. Because if you make coal cheaper to mine, that was good for our industry. And the exporting around the world. So we were, wherever there's coal, ever deep coal, there's probably going to be a long wall. And in most of those countries, we were there. So Australia, Canada, the States, Mexico, Brazil, and so on. And in fact, I think there's 4 of those countries I didn't visit personally. The rest of them we were going to. And Paul, who's here tonight, she's probably told me I missed a few. But it was a real world business and a world-leading business. Royal recognition, I thought this might be interesting this week. In 1981, we had the, Duke of Edinburgh came to visit this is the Jubilee in 1971, so this is 50 years after the founding of Dowty. Dowty Mining won 6 Queen's Awards, and here's one of the good people holding the Queen's Award emblem aloft here. This lady here, you'll see she's got her dog, she's partially sighted. Here she is examining this carefully. Queen's Awards as a recognition of Dowty's high technology and exports. So then was the demise, unfortunately, of British coal in the late 80s. First of all, the high-powered mining machinery, obviously we were putting in, increased the output per face. The problem was they couldn't get their costs down fast enough to become competitive. And also the demand for coal was falling because gas was coming on stream. Historically, you weren't allowed to use gas for power generation. It was regarded as being a premium fuel. But then they had too much of it, and they started using it for power generation. And the number of faces, when I was first involved, I remember there were 750 working places in British coal. It wasn't long before it was down to 100, and then it was down to 50. And demand for machinery was slumping. Dowty decides to divest of its mining division, but not an easy business to sell because the future was not looking at all good, almost everywhere actually. The best option was the management buyout, and in '89 we changed the name to MECO International. MECO means Mining Engineering Company, and they had a strong name in Worcester in the same product field. Moving on, things didn't improve in the early 90s. Coal imports were coming in, gas power stations were increasing, demand went down further, machinery declines further. So at the time of the buyout, there was about 10 faces being bought a year. 3 years later, it was down to 1 face a year. There just wasn't space for 2 manufacturers. So no longer room. A vicious price war developed between ourselves and Dobson Park, which was inevitable. You wanted to fight for the business, but the trouble was that even if you won the business, you lost money because the price was so awful. And if you didn't win the business, you lost money because you hadn't got the order. The merger was the least bad option. In a merger of very comparable companies, it couldn't all be one way. We couldn't say to them, right, we've got a great deal for you. We're merging the 2 businesses together. All the Dowty ones stay open, all the Gullick ones shut. Worcester was so strong, there was no, relative to the conveyor business in Gullick, there was no way that could close. And it was a sad fact that it was either Ashchurch or Wigan. In terms of facilities, you could have tossed a coin on the scale of the 2. All of us here know which one had the best engineers, but many people were from here finished up going up to Wigan. In due course, Wigan also closed, and some people did the return journey and finished up back at Worcester, because that's where there's. If you go to a modern longwall face, I took this off the Komatsu website. This is from today. The people here who worked at Dowty Mining recognize every element of this from the 1980s. The supports look the same, they're a bit bigger. The conveyor looks the same, it's a bit bigger. The electronics look all the same name. If I move on to the last slide, you can see the 2, this is just looks a bit smaller than the one before. I think that the people who worked in the mining industry for Dowty have a huge amount to be proud of in what they did in taking the industry forward from where is Ashchurch relative to the coal industry? We're hardly based in Sheffield or Doncaster, and hardly sort of with the benefit of being in the middle of Appalachia or New South Wales. And here was a business that really was preeminent in its field. Thank you. Well, thank you.